Welcome everybody to the American Space Museum. I'm Mark Marquette. You're with us today to stay curious with Mr. Gary Allgire, a NASA structural engineer. How you doing, Gary?
I'm doing just fine, Mark.
Well, you're not doing that anymore. You retired a while back there,
I've
but
been retired 24 years.
well, your brain is really lucid of what you do remember.
Yeah.
Gary, tell everybody, we've got a lot of new people that watch. We're going to talk about the Apollo 14 landing on the moon and the docking hatch. It's a legendary problem of this. How did you get to the position in 1971 when you were dealing with the docking latch of Apollo 14?
It ended up that my lead engineer was more interested in going to meetings and doing documentation and stuff, and he kind of let me do what I wanted to do around all the spacecraft hardware. And I got interested in the docking probe, and then we happened to have the designers at Kennedy Space Center. Got to talk to them and became good friends, and every time I'd go out to California, Downey, I'd always go by and see those two gentlemen out there, and they gave me
What
a
were
lot
their
of insight.
names?
Earl Holman, who was the designer of the new side hatch, and he also designed the docking probe. And then there was George Campbell, who did the docking latches. And then we had another gentleman in there called Scotty. I don't know Scotty's last name. That's all he always called him Scotty. But
Okay.
anyway, he did all the electrical work on any of those devices. So there was a combination of three, but Earl Holman was really a super smart engineer.
Well, we're going to get into that with Gary. If you've got questions, please do. Gary, how many years did you work for NASA?
33 years.
And you started with the Gemini program?
I started with actually the first launch that I was here for, which is I came in January of 1968. So I think in March we launched Apollo 6, and then my first manned mission was Apollo 7.
Yeah, we did a great program, Gary did last year on Apollo 6, the first all up, bold decision to do all that, thanks to George Miller. One of the NASA suits that was a leader. Want to say hi to Tom Usiak watching. Cliff Watson's down there saying, "Good morning, gentlemen." He's in Pomona, Australia. Is it eggs and bacon for brekkie there? What you having there, Cliffy? Cliff sat in that chair a couple times and talked to us. You've seen him, Gary. Gary watches our show religiously, and appreciate that, Gary, that you do. We've done this a while. What is, I characterize the outreach that we're doing and how important that is for you to be a national treasure, one of these space workers.
Well, I don't consider myself a national treasure.
We do.
But as far as a museum, it's great to be able to talk to people and go through, and as we do a tour through the museum, I get to be able to talk and relive some of my experiences that I had working on the Apollo program and also working on the space shuttle when it first got here. So that's a joy. It's a joy to meet all these other people and find out about where they're from. And it's amazing how many have stories about they've either met an astronaut, they knew an astronaut, their family knew somebody, they'd gone to the high school and so forth. And we had a guy from France here the other day, or a Frenchman from Canada that was very excited. In fact, he wants to be a docent here.
Yes, right. Talked to him yesterday.
Yeah,
we have a lot of foreign people in this.
We do.
I think almost 25% of our guests are from Europe or Canada.
I've had people from Argentina, France, Germany, Belgium. Really the kind of the coolest was two young guys from Russia that were here, and
I remember those guys.
Yeah, they came through here. Yeah. And Japan, we have a lot of people from. So basically, we get them all over the United States.
Gary's a snowbird. He goes up to Georgia when it gets too hot here with his lovely wife, and but you're usually here Tuesdays and Thursdays doing docent talks, and we appreciate all that you do, Gary. We really do, and we. He helps us at other events and supports us by showing up at Shuttle Fest and stuff like that. Wanted to say hi to Gary Gerald, our favorite Vidalia onion farmer up there in Collins, Georgia, and Tom Celentano's up in Connecticut. Cliff Watson's having coffee, he said, and it's raining and hot in Pomona today. All right. And Mitch Rothman of Man's Space. That's a Facebook page you need to go to. He says, hello, Gary, Mark, and Marty. And hello, Doug Forrest, our artist, and who's out at in Los Angeles there. And great to have Marty back in the saddle. Marty, thank you for doing remote 2 days this week, and while you took care of some family business. We want to talk about your Lunar Module number 8 today. So keep your finger on that UCX family microphone there, and help Gary here as he tells an interesting story. I want to wave hi to little Mia, little 2-year-old Mia. Gary's watching with Dave Stange. Hope you learn your planets, Mia. Mercury, Venus, Earth, Mars, and then what's next? Mia, tell Grandpa after Mars. Gary, let's set the stage a little bit. Well, let's do a little.
Well, you got some other stuff to do
Let's
first,
let's
right?
do a little business here. First,
Yeah.
we want to say our charity auction is Saturday, February 8th.
There we go.
This Saturday, noon to 5. You can bid now. There's some Apollo 14 lunar maps that we talked about yesterday. For them to their trajectory over the moon that Stu Rosa was probably using to do photographs. So 350 lots. The bidding starts out at $100. This is not your yard sale type of stuff. It's the real stuff in there. And Marty, I see that you got the envelope I had for you underneath there. Thank you, sir.
Thank you.
What they have really is cool is things like, and I say we, it's Bid Again Auctions and Chuck Jeffrey, who I think you met a few times. That's a real photograph from Apollo 8.
No.
And it's a red lettered one, meaning VIPs and space workers like you would maybe see this in that brown envelope thanking you. And there's a transparency there, taken a big slide, taken off the original film. And, this should go for, Gary, somewhere around $800
Oh, okay.
to $1,000. These things command a lot of money, and this is a real A Kodak paper print there. So this is how it's detailed out on the auction. It's fun to watch, and you can watch for free, but you buying something helps the American Space Museum. Well, let's set up a little bit, help Gary. The Apollo 14 mission after Apollo 13 has a lot of moving pieces and parts, okay?
Oh, definitely.
And part of it involved Al Shepard,
Yes.
the chief of the astronauts, and his good buddy Deke Slayton, both grounded for medical reasons.
Yes.
When Shepard had his ear fixed for Meniere's disease, he put himself as commander of Apollo 13, correct?
Correct.
Now, I'm going to throw out there, Marty, we should have had a question today, but I'm going to propose a question, and now I don't see, there's Steve Jokums. When Al Shepard checked into a hospital to have Meniere's disease, what was the alias he used? Okay.
That's a good one.
Who knows that? What was the alias he used? So, Gary, this was actually the Apollo 13 crew?
This was.
Tell us about that.
Well, they had Shepard, and I don't think Stu Russo was on 13. I don't know the original crew members that they had, because there was a swap out. Because of Alan Shepard's came in, they were going to sign him to Apollo 13, and the Apollo 13 original one was Stu Russo, Gordon Cooper, and Ed Mitchell. So I think is right.
Okay.
And
Cooper was going to be the commander.
Yes, and Cooper had a very bad reputation, and because he did not want to do any training. In fact, he was a backup crewman on the Apollo 9 that I worked on. And he, as a backup, he should have been flying on Apollo 10, but he didn't get to do that either. And so he never flew again, but he was assigned originally to Apollo 13.
Mm-hmm.
Okay.
Yeah, it's a very interesting personality there.
Yeah.
Very talented, of course, Mercury and Gemini flights. Here's the three of them getting together with their patch there. Basically, 15 minutes of space experience between the three of them.
Yeah.
And of course, that's Alan Shepard. I was at Cocoa Beach today and drove by Alan Shepard Park. I almost wanted to shout out, "Hey, he was on the moon right now, walking! Oh,
Yeah.
54
Yeah.
years ago today."
Yeah.
And now Ed Mitchell, a very good friend of the American Space Museum, raised a lot of money
Yes, he
for our
has.
Spaceview Park. He was, I wish I could have met him. Here they are in training at probably the flight crew training building there. Russo, shock of red hair there. The admiral, he later become admiral, the Shepherd, and then Russo, Edgar Mitchell.
Now, Ed Mitchell, when he was here, I got to interview him and film some of the that you see on YouTube. I filmed some of that. Personally, it's not the same as what the lady that was filming it, but he had mentioned that they were on the 13, but because of Alan Shepard bumping Gordon Cooper, the NASA wanted to give him a little extra time for some training because he only had that 15 minutes. So they swapped with 14, which was Jim Lovell.
Lovell was 14, and
Ken
Borman,
Mattingly.
Ken Mattingly,
Lovell, and Fred Hayes.
Yeah, Fredo.
Okay, so they got, as Ed Mitchell has stated to us, they got the good vehicle, and unfortunately Jim Lovell and his crew got the bad vehicle because they ended up on 13.
Yeah.
And what people really don't, they don't really say this about Apollo 13, and I'll be covering 13 later this year, is that Ed Mitchell and Ken Mattingly, when they had the problem, Ken Mattingly went into the command module, which the crew gave him a bunch of recognition during that flow, during that time, because of what happened to him. But Ed Mitchell went into the Lunar Module. And so they never have mentioned him, but he was very important. Both those two guys were very important to the success of that Apollo 13.
Yes, he's a very interesting person also. Created a paranormal society. The Noetic Institute believed in ESP, tried to do ESP experiments. This was really a fabulous mission, though, Gary. It had a rocky start that Gary's going to talk about, but we'll talk about the end, some of the accomplishments. There was this, things, they didn't get to Cone Crater like they wanted to because it was so deep. The regolith there was like a big snowpack up to your knees almost. So you learned from that. Even though they didn't accomplish their goal, they learned a lot from it. These were great ambassadors afterwards of their mission and the most accurate landing and splashdown of the Apollo program. Boy, and when I told Laura Shepard Churchley, the daughter, that at events that I see her at, she's like, of course, Dad was always precise, on there. So the drama started here a little bit. Here's the Apollo Command Module and Service Module. Okay, of course, the service module, the astronauts do not get into that back part there. And here it shows the Apollo 15, 16, 17 configuration.
That's Apollo 15 right there.
Sim bay. Okay.
That's Apollo 15.
And how do you know for definitive?
Well, for the sim bay, but see that little pole sticking out the side of it?
I do,
Okay, that was a sensor on the end of that pole. And it's very interesting how they did that because it's a little box that we put in there. It's about that shape of a box and is about that deep, and the antenna is rolled up in there. Now it's flat. As it comes out, there's a die that will force that flat piece of metal to roll up into a roll and make it a tube, and as they would go out, and if it came back in, it would reflatten that back out so it'd go back into the box.
Oh, interesting. But now I know. How about that?
Yeah.
It's so the minutia of different things like that to identify it.
It was a gamma ray experiment. We had another box above it, a big one, which was a big part of the gamma ray experiment.
Well, here you see the docking probe at the end here. Okay, that's what we're going to talk about. By the way, Steve Jokums, Marty, I think Steve may have answered the question there. Yeah. Why don't you tell people what was the pseudonym that Alan Shepard checked under when he had his ear surgery?
Well, it's just like Steve Jokums says. It's Victor Poulos, if I pronounce it correctly. But,
Poulos.
Yeah.
And now, Polo is a Hispanic derivative for chicken. So did he check in as Victor Chicken? Okay.
Yeah.
Steve Jokums will know the whole story behind that, brother. So, And Mitch Rothman said that Shepard then got plenty of time to train after the delay, of course, of 13 in the investigation. Maybe that's why he was so precise, was he was very fresh on that. I would have loved to have met him, really. Did you ever meet him personally?
No.
Oh, yeah, Alan Shepard.
Oh, not Alan Shepard, no,
Okay.
just Ed Mitchell was
Ed
the only
Mitchell.
one of the crew.
Well, the picture on the left does not properly show the docking probe on there. It's an early concept, and then the skin off of the lunar module number 8 in the assembly line of Grumman lunar modules, and Marty, of course, that's Lunar 9. Of course, that's the Earth in the background, so that's Apollo 9 in the
And
background
I think
there.
does it have an extra?
Yeah, go ahead, Marty.
We got a question from Dave Stange. He says, I know they brought the docking probe back on this mission. When did they normally dispose of it on other missions? Was 14's probe reused?
The first part of your question is they don't bring them back, except for 14 was the only one they brought it back. They store them in the lunar module, and they separate the final time coming to get off when they dock for the last time on the moon, circling the moon. They actually fire some ordnance that cuts the whole docking ring off, and the docking ring will stay with the lunar module.
I saw you explaining that to that gentleman from France.
Yeah.
I didn't know that. Hello, Elena Adkari. Thank you for watching today, Elena. And thank you, Dave, for a good question.
The answer to the second part of that question, was it reused? Now, I've heard two comments made. It was reused on the second Skylab mission, Skylab 2, when Pete Conrad docked with the docking system on the Skylab, and they ran into the same issue where they couldn't dock because they had a locked up capture latches. Now, he did something totally different, and we'll explain that more when we get to the Skylab.
Did you bring those samples in?
Those were not
okay.
relatable. Those were for the Apollo-Soyuz test project.
Well, Mitch thinks it was reused on ASTP.
No, it was not. Not aware of that. The only one I've heard rumors was it was reused for the second Skylab mission with the first crew. That's the only time I've ever heard it was reused. That's in print, and it's also, I've heard it on YouTube someplace. Somebody made a comment. Now, when they brought it back, they took it to Downey. They did a preliminary investigation, just disassembled a couple of parts just to make sure. They did a microscopic looking at where the tension tied to it, and I think it did 100 cycles to see if they could make it happen again. And they did it one time. It did lock up, but they had to put the probe horizontally and hang a weight on the head, and that's the only time that it not locked up. So they really never came to a real conclusion of what caused it. And so we're going to talk about the mechanism and what I think happened, and also how close they came to having to abort the actual landing on the moon, because unfortunately, the JSC for some reason didn't have the proper guys in the control room to really tell them how that thing works, because they so misunderstood it. And same thing on Skylab, they so misunderstood it. And some of the stuff that's out there is totally wrong. What they said, how they fixed it, and they didn't.
Well, let's get into the totally right way here with the one and only Gary Allgire. As you see, they're structural engineer for NASA, and if it doesn't have fluids or electrons going through it, Gary knew a lot about it, and he's done a lot of research. He looks at all the YouTube stuff you're all looking out there. So this is our moon ship. I love telling people this is what we took to the moon. Where's the moon, left or right, Marty? Did they have no, they would have the bell of the service module facing towards the moon.
They changed around a lot.
They had to barbecue.
Well,
What was the barbecue?
The barbecue is a roll, and that is to control the temperature from the side looking at the sun is hot. The side is away from the sun is cold. And so they barbecue it just to keep it an even temperature on the vehicle as much as they can for thermal expansion, contraction. We don't want warpage or anything like that, even though the metal is actually pretty well protected by either some type of a cover over it or blankets or whatever.
That's it. And here we have Rusty Schweikert and Jack Lausma signed it. So send me a $600 bill with your address on it, and I'll send you this happily, properly packaged and so forth, because it's worth every bit of $600 with
Definitely.
those two gentlemen on there. It's a $300 model anyway. Well, we set up the drama here. They get up into Earth orbit. The third stage, the Saturn 1B's got the slaw with the lunar module inside of it. I didn't show a picture of that. And what happened, Gary?
Well, first of all, let's look at what modifications that were made to 14 based on what happened on 13. And this is good for all the spacecraft from that point on to the finish of the program. And what they did, let me get out of the way here, is
here's your slideshow.
they added a third oxygen tank
right there.
in one of the other bays. You can see it up there to the left of my head. There's an oxygen tank. The other thing that they added was a 400 amp hour battery in the other bay across from there to support fuel cell number 2 from that time forward. And in the crew compartment, they've changed some of the panels to give them for the readout of the third tank and the battery. So there's some changes were made to that. To the lunar module, they added some anti-slush plates in the fuel tank and the descent engine. So that because of what happened on Apollo 11 and Apollo 12, they got a low light come on. It says there was low fuel when they really were not. The sloshing of the fuel in the tank gave them a false reading, so the baffles stabilized that. So that gave them the correct reading for how much fuel was still left as they landed on the moon.
Very interesting. Dean Babcock has a question, Marty.
Yeah, Dean's asking, if they weren't able to dock after leaving the lunar surface, was there a contingency plan to do an EVA to get back into the command module?
Yes, they could, because they did that practice on Apollo 9. They had handrails on the outside of the command module, and I think they had some. I'm not sure they had handrails all the way around on the lunar module, but they did transfer up to the lunar module during Apollo 9, and
But they didn't do the exact switch
no,
inside
they
like
didn't
they
do
want
the
to, because
exact switch. No.
Schweikert was a little
No,
queasy, I
no.
think, from space sickness.
Yeah, that's kind of was risky because they really didn't understand why the latches didn't latch, and they've, like I said, on the 6th try they got it to latch, and they went on ahead and
Well, let's get into that here.
and considered going to the moon. This is just a kind of a drawing of the lunar probe. I have colored some blue handles. The blue handle right above my head doesn't do anything. It's just something for the astronauts to grab, because what they're going to have to do is basically collapse the 3 legs that it's holding it into the tunnel itself. And you'll see one up on the, we'll talk more about these a little bit later, but there's one up there with the yellow tab on the end of it. That's one of the 3 legs, and that keys it to exactly what position it's supposed to be inside the tunnel, because it will match a little marker on the opening with its yellow. And we have, I think, 4 handles that are used to open, to release latches, to collapse and extend the legs, and do a couple other things. We had 2 electrical connections there, plugs, and Marty and I have been discussing these. One of them I knew for a fact when they got when we put it in at the pad and put it in the orbiter, and at the pad, one of this part of the closeout, we would remove the tunnel tunnel hatch, and then we had techs would go in there and disconnect it from the probe, and then run over and connect it to the ring of the docking latch. And this provided power for 2 of the solenoids that will release the probe so that it'll extend out 10 inches. There was another connector that I'm not really sure what it was for. I was thinking that it was used to, once we're docked with the lunar module, we would cross over and plug the other end of it into the lunar module. But Marty and I have discussed this, and we're not sure exactly how they electrically connected the two vehicles once they were docked. Unless somebody out there knows the answer. I can't find anything.
Now we'll be looking at here, this.
Now this is an exploded view, and unfortunately I'm blocking most of it, but this is an exploded view of the docking probe. The probe weighed approximately 55, 60 pounds. And
Substantial.
Substantial, yes. And one of the questions we had on Apollo 9 is prior to the crew coming in, we had to put this, somebody was worried about the astronauts not being able to reach over their head, take the hatch down, and then take the probe out, because the hatch weighed probably 50 pounds too, somewhere in there. So they came up with this big metal kludgy looking hoist thing that they would set on the floor in the center of the command module. It had a hand crank on it, and it had two adaptive plates. One was for the hatch, and they would crank it up, grab and release the hatch, and then they would lower it down, and then they could take it and put it underneath the seats. And then they would put this other plate on there that would interface with the docking probe, and then they would collapse it and they could lower it down. And the technicians were struggling with this, and they called me into the cabin. So we sat down and I was talking to them, and they said, "This thing is so clungy, it's more dangerous than it is anything." I said, "Yeah, I don't know if we could get this thing out of here, and maybe the crew could go ahead and do it by hand." And so we discussed it. I said, "Let me go out and I'll talk to somebody who will talk to somebody." And they got with the crew, and the crew says, "Yeah, we'd be fine. We'll go ahead and remove the docking probe and the hatch by us. So we don't need the half thing in there." So we were glad to get it out of there, because it took up a lot of room. Took up as much room as really as an astronaut physically. And so that was so for all those missions after that, they actually physically raised and lowered those probes and drogues.
Well, there's the real article,
Yeah.
or demonstration or test model.
This is probably a display model. I mean, it was a working model that they had at JSC. You have the docking ring. I think where you see that brown area down there. There, inside that area would have been a string of ordnance that would cut the docking ring up loose from the command module, so it would stay with the lunar module. You have two O-rings on the upper side of the docking ring itself that provide a seal between the two vehicles, right there. And then you have the docking probe. This is in the retracted position. When the astronauts will flip a switch and it will release the probe, it will extend out, and it uses a spring to make it go forward. It'll spring out to 10 inches, and then the head will float, and when they engage the apex hole in the
We're looking at the
cone,
springs right there.
yeah, there's the springs. Now up on the left-hand corner over there, you'll see a yellow device. I hope it shows up.
Yep.
That's called a spider.
Okay.
And it has a rod that comes down, and that is what controls whether it's in a locked position, it's in a release position, or it's in a cock position for the three latches that are in the probe head. And then over here on the right, you can see we have four GN2 bottles that are pressurized to 5,000 psi. The astronauts will select one of the four for a retract, and then so they have actually four attempts.
That's the nitrogen bottles.
Nitrogen
right
bottles
up
up there. Okay, and there's there's a cylinder inside of a cylinder, and I'll explain that a little later. You have three big legs that are attached to a gas and oil-filled attenuators that help keep the spacecraft aligned as they retract in. Retraction is very quick, by the way. You can see the size comparable to a gentleman from JSC that's showing somebody something. You can see
Mitch Rothman asks again, how much did this weigh on Earth?
it was 60. I don't have the exact weight, but it was, remember from what was quoted to me back at the time, was 55 to 65 pounds.
Tom Usiak has a question. Go ahead, Marty.
He's asking, Gary, the 14's landing was supported What direction do you think Apollo would have taken, especially with congressional support beginning to dwindle?
That's what Ed Mitchell told us back when he was here at the museum. That was what he was really worried about. Is if we didn't, we couldn't go to land on the moon, we would have to do either just go up and do a free return around the moon, or turn it into Apollo 8 and just circle the moon until the time to come back home. And he was worried because it was back to back. This would be back to back 13 and 14, which would be critical. And he was really worried that Congress would shut the program down then.
I think really an underestimated
Yeah.
return to flight. They don't call
Yes.
it that, but
Yeah.
you're going to talk about Apollo 13 and really emphasize the stars were aligned for those three guys.
More than that, you will be amazed how much there's Apollo 1, Apollo 6, Apollo 9, Apollo 13, Apollo 10, were all involved in Apollo 8, were all involved. What they learned and did in those missions was applied to saving those crew coming back from the moon. If we hadn't done that, what we learned and knows, we wouldn't have made it.
Well, we can't wait to have Gary back to hear that here in a month or so. And good. Mark Geiger's just watching. He said he was just watching the live video from the docking, and the video is excellent on there. So Gary's going to talk about that as they were in Earth orbit, had to get attached to the lunar module, and things just weren't working out. What you got here next?
That's just another picture of the. Go back here just a little bit. You can see the electrical cords. They're coated in blue. Again, there's two of them. One of them that you see are going up to the solenoid motors. There's two solenoid motors as a backup.
There,
And it releases a big hook, so it allows the probe to extend out. Now, George Campbell gave me one of those.
Oh.
That thing. It weighs about 5 pounds. It's here at the museum, buried somewhere in your warehouse. And we could always put it on display. But it has part of the shaft. But it's a prototype. It's a development piece. But it's a working, functional piece of equipment.
What's the arrow pointing to at the top up there?
Let's see here. What did I point to?
Right at the top where the docking cone is.
That is the. Let me see here. I don't have my pit. I should have brought my tablet up here. I forgot.
So at the top, Gary, upper right. Marty's going to point it out there.
Yeah, I pointed there. That is the hook. That is the hook that holds the docking probe in the retracted position.
Okay.
It's a big, heavy hook.
All right.
And I'll explain why it's so heavy. This is the coas that the crew uses when we do our docking test down here with the lunar modules. The crew's in there, and they're sitting in the couch. And as we do the mating to the command module with the lunar module, there's a docking target that's been built into the lunar module. And what they're going to do is once we dock, he will align the coas. He has capability to align the crosshairs that he sees through that coas, and he'll line it up to the crosshairs on the target, so that when they actually do the docking test in orbit or going to the moon, they can actually make sure that they actually are lined up perfectly.
The target's actually of something painted or
No, it's a standoff. It's about a foot off the deck of the lunar module, and the one on the lunar module is pretty big. It's about this big.
Okay.
Now, originally thought was they would use, since the lunar module has the radar on it, command module does not have any radar. So the plan was originally, as they came off the moon, they would use radar to find the the command module in orbit, and they would do the docking. So to do that, over on the right-hand couch in the forward-looking window, they would put a small docking target in there. And we did on Apollo 9, we did the first test, and they were able to get a little ladder in there, and they crawled up and looked through the coas at that target, and they couldn't see it. It's too small. So they reversed it. They would use the radar to get them in position, but the actual docking would be done by the commander in the not the commander, but the command module pilot I get mixed up between command module and shuttle too much, but they would do the actual docking.
All right. Here's
This is in a, probably out of JSC, or more likely it's out of Downey. They did have a mock-up out in this building, and there's Wally Schirra and Don Isley is in the
Above your
center
head
seat.
there.
Yeah, in there. I mean, I guess I have to get out of the way, but anyway, that's them practicing. But this shows you up there, and above Wally Schirra's head is the COAS that I'm talking about. And he's looking through the forward
where the
looking,
wires
where the wires are attached to it.
on
Yeah,
the
it's
left.
electrically operated. It's basically a flashlight with a 45-degree piece of glass that you can adjust the reticle
The
on.
reticle
Yeah.
in there, illuminated reticle. Huh.
And they got fancy cushions back there. This is actual Apollo 14 docking test that we did with the lunar module. What we would do is we would just.
Is it? You're not in that picture.
Yes, I am. I'm
The
down in
left?
the lower left
All
corner.
right. Yeah,
That's
look at
me.
that handsome
Yeah, I was
devil.
22 years old back then.
Oh my gosh.
Yeah.
Oh.
And what we do is we cannot operate it we do in orbit because we cannot fire one of those GN2 bottles. If we do, we just have to take it and ship it back to Downey, California to take the whole thing apart to put a new one in.
Uh-huh.
So what we just use gravity is we just come down, we get a capture, and once we get a capture, we'll just go ahead and physically lower through the crane. We just lower it down until we hit the triggers on the capture latches, and then we just and then we dock that way.
You still have your Rockwell smock and hat?
I never had a Rockwell one. I had a NASA one. Yeah, I'm not a Rockwell
Well,
concept.
you're wearing, if that's you on the left, you
Now,
got
I'm
one.
down there below. I'm down in the lower corner with the headset on. I'm looking away from here. I'm talking to somebody else.
Oh, okay.
Let me see. Yeah, there I am. Right there. Oops. Get my hand out there. I can do it. No, I can't. Anyway, that's me right there.
It's a Rockwell smock.
Yeah.
Has it got a Rockwell smock?
Yeah.
Oh, my word. I must have not had any NASA ones available.
All right.
That's unusual. I forgot all about that. Huh. Normally you don't wear. This is at Stafford Air and Space Museum out at Oklahoma City.
Mitch Rothman, you've seen that, as have
Yeah.
I, several times.
Yeah.
Has so much Russian stuff there, including a lot of signed vodka bottles.
Yeah.
By cosmonauts and astronauts, right, Mitch?
Yeah. This is
Yeah,
something you normally don't see, is the backside of the docking cone, and you have a docking probe there, and you see the one with the yellow tab. That's the leg that goes into the docking rings itself. In the background is our version of our side of the Apollo-Soyuz test project docking system.
Mhm. Interesting. And that's General Stafford. That's Leonov,
Leonov,
depicted in his suit there on the right there.
Yeah.
And there's another picture. We'll get to Gary Geiger's question here in just a minute, Marty, as well as Mark Thal. There's another look at that docking probe. It's exciting to see this stuff up close and know that this is sort of like the template for how things are done. And there's a question also I saw where you can talk about how this is translated into today's version of docking.
Okay, that's the apex up there, the hole. That's where the docking probe head has to go inserted into that. It doesn't go in all the way. It goes in enough for the latches to clear, and then they'll pop back open, and then they'll lock in the open position.
On the other side.
Yeah, on the other side. Yeah.
Uh-huh.
And it has three hooks that they put levers that they could take and connects to the lunar module ring. This is just an actual photograph of the panel in front of the commander, and there's
Circled
three
there in
switches.
white.
There's only three switches that controls this whole system. The farthest one on the left is a protected one. It has a cover over it, and you flip it up, and it only has two positions. And one is called extend, and the other one is retract.
Now this is in the command module.
This is in the command module. And the two other switches next to it, there's a prime system and a backup system. And what that, just go to the next picture here, it explains a little bit better. I've highlighted them by putting them in red. And those control the four GN2 bottles. ACE, the prime system, you can go up one, it was labeled one, and down two. So it's one of the two that they can select, and then on the secondary, they can again select one of those, the other two bottles, one individually. And above that is called talkbacks. They're normally gray, and when the probe is extending out, it'll go barber pole, and they have two for the backup. And when it gets to the full extension, it'll go to gray. And then on retract, it'll do this just the opposite. It'll be gray, it'll go barber pole, and then gray.
Okay, we're going to look up close-ups of those latches here
Yeah.
coming up. But Marty, we have a couple questions for Gary.
Yeah, Mark Geiger is asking, Gary, how close was it? I'm not sure what he means by the S1VB, whatever that is, to losing power before final docking.
Okay, they during the docking of this mission, which took six attempts, and if they hadn't done it on the sixth attempt, that would have been it. There was no coming back from that. If it failed on the sixth one,
Why? The consumables of the
no,
fuel?
they thought that they could take it out, release it, and bring it back into the crew compartment where they would look at it. And there's absolutely no way they can. It's stuck in the open in a extended position. They cannot retract it. They cannot do it. And the only way they can retract it is make sure that they're if they've attached to a stroke. And I'll explain that a little bit in a few minutes.
How about the power of the rocket that the limber's in?
The limb, where we're talking, I think you're talking about the S4B, and the limb's still in the S4B. How long do they have before they cannot work with that? And that was a question that was asked by the crew, and the answer back was, at first time they got an answer, was the batteries are the key point on the S4B because they have attitude control. And if they lose the batteries, then they lose attitude control, and it'll start rolling and pitching and yawing. And that was a 6 hour, they told them it was 5 to 6 hours time on the battery. It came back later and said it was 13 hours.
Okay.
But the total time it took for them from the first attempt to the last attempt was 1 hour and 48 minutes.
And they're orbiting the Earth.
No, they're
No.
on their way to the moon.
Oh, they had done translunar injection.
Yeah, that's the first thing they do.
Yeah, right.
Once-
Yeah, that's
once-
dumb of me. Sure, yeah.
Once
that's
they
yeah.
on translunar injection, they separate from the slaw. They fly out a little ways, turn around, and come back and then dock with the.
A lot of drama played out there
Yes.
that the media didn't understand or care
And
about.
also
I'm sure.
during attempts 4 and 5, they had to back out and stop because there was a pre-program of the S4B had to do a non-propulsive venting of the fuel tanks.
Oh,
So
my.
they sat there and watched it. And they're the only ones probably ever got to see this. They could see the particles coming out from in the four
Wonder
corners.
if there's a movie of that.
Yeah.
All right. And another question, Marty?
Yeah, Mark Bell is asking, excuse me, with the docking test with the command module, was it just the ascent stage or was the entire limb used?
No, just the ascent stage. We rotated it upside down and brought it down. It took some very special equipment to lower it down because we had weight restrictions. We couldn't put more than 5,000 pounds on the command module. Of course, the lunar module weighs much more than that. Plus, when we did the actual latching, it's going to pull rapidly down the lunar module, and we couldn't overstress the lunar module. So we had another device that would control the rate that it could be lowered in there. It was very critical. That was run by Grumman, by the way.
Marty's got a new viewer that has a question on that UCAC family microphone.
It's from USS LKA 116. Sounds military. Sir, if the docking was unsuccessful, could it have potentially ended the Apollo program?
Well, that was the thought. We discussed that a few seconds ago. But yes, Ed Mitchell was very, very worried about that. Of course, when I was sitting there listening to it back in real time, I was never really concerned about that because I really thought, and I had a misconception too. I thought, well, on the ground, we go ahead and we push it together. Why can't we do that in orbit? And they talked about that. And I think Jim McDivitt suggested that because he was Apollo 9 crew. And then somebody came back and said, no, you can't do that. And it wouldn't work. And I never quite understood when he said that, but getting prepared for this, I finally figured out why he was correct in saying it would not work.
You're going to tell us that.
I'll tell you that.
All right.
Okay.
Thank you, USS LKA 116, for joining the party here. You've had a lot of friends that know a lot about space history, and that's what our program's about. Gary Allgire giving us an in-depth view of a real hidden anomaly of the space program that almost terminated Apollo 14 landing on the moon and could have ended the space program. Those things are very political, how they swing, and when things aren't going someone's way, they grab their rockets and their toys and go over to the corner and don't play with you anymore. So you've seen it. You've seen the Constellation program. You've seen the
I've
Artemis.
seen a lot of programs.
Yeah.
The Dinosaur, you name it.
Manned orbiting laboratory.
Yeah,
So-
mole, yeah.
Well, we're going to get into the details of the latches here
Okay.
that I'm fascinated to learn more about with you all. Go ahead,
This
Gary.
is a close-up of the head of the probe. I have a red arrow there, and that is called the trigger. And this is the reason why the concept of being able in orbit to push and force your way in is not going to work. Because without that trigger being folded inward as they go in through the hole, that sets off and releases the latches to lock. And since on this particular mission, they acted like they were physically locked. Because when they went in that first time, well, actually they went in twice. They went in and they tried to dock, they backed out a little bit, and then they went back in again with using a little more force. And it actually puts big scrape marks in the inside of the docking ring drogue rather, excuse me. And they could see that when they backed out. They could see those 3 scratch marks in there being reported it to JSC. So that indicated that those latches were totally locked out. So because of that, they cannot get into the hole any further than what the interface is on the latch itself, which if they had gone ahead and tried to push the two together, they would have never been in close contact to the docking ring.
I
They'd have
see.
been standed off, and they would never have fired the 12 latches.
Now, Manned Space Mitch Rothman says, would Gary mind explaining exactly the job you were doing or your role during this Apollo 14 mission?
During the mission, I'm just an observer. I'm actually working on another mission by then.
Oh, okay.
They were at 15, I think, was working on that. So you're tied up. Once one goes, you're on another mission right away.
Well, you were a structural engineer for what at the time, or what?
Well, I was a structural engineer in the NASA side, and we had responsibility for all the mechanical structures, mating operations that
So
we did.
everything.
Everything, yeah. We owned everything except, like I said, anything that had electrons running through it or fluids, we didn't own that. And I know nothing about them. Basically, we didn't have time to.
So you were already working on 15 and just
Yeah.
Now, were you consulted on these problems?
No, they weren't. We have a room that when they're on mission, we can go into this room down the hall, and they'll be tied into the loop, and you can hear the mission control. You can hear everybody talking, so you know what's going on. And there'll be a set of all different kind of engineers. And you're not mandatory to go in. You just go in when you think you want to hear something, or if they're doing a problem that you're aware of, that you might go in and listen to see what. And if you can help, then there's a way to go ahead and get on the net and talk to them. But by the time
Not the net as we think about it today.
yeah, no,
The network,
Yeah,
not
network.
internet.
Yeah, the network. Yeah, not the net. And so I went in, I think, once or twice on 13, once or twice on 14, and the other missions I never went into that room.
See, this was one of 168 things, I believe, is a number that have to go right
Yeah.
for you to go to the moon and then come back alive. Yes, Marty, go ahead.
Yeah, USS LKA again is asking, so during 15, what changes were made?
15, there was I don't think there was anything made different. They just, again, we did a docking test. There was no changes to the docking probe that I'm aware of. We didn't see anything. Now, I never have a set of complete drawings of the docking probe. I just had a little bit and not a lot of knowledge. I talked a lot to Earl Holman on the phone, or George Campbell on the phone, many hours with George Campbell trying to get the latches to work properly. But that was the most difficult part, was the latches itself, to get them to work.
Marty has another question.
Yeah, Mark Geiger's asking, Gary, did they ever find out for sure why the latches would not lock?
No, they did not.
Let's look at them latches up close. Up there.
Okay, but let's go back here. Now, we have to start off. This is how we launch. We have the boost protector cover with the launch escape system. That's the first thing we put on when we go into the VAB. We bring the launch escape tower. It has the cone section of the boost protective cover.
I didn't think about that being over this whole thing.
And we put that over, that's the first thing that goes down. And it attaches just like, I guess through where the lifting attach points are, okay, with the launch escape tower. Now, to go back, stay back there. Now, the pink thing that you see is called a tension tie. What we have to do is, now, I've never did this, and it was a long time before I figured out they actually did this because they didn't tell me.
What, the pink off your shoulder?
The pink off, this pink right up here.
All right. That
Okay,
could
right
be
there.
lavender
Or pink or lavender. Anyway,
right.
the ordnance guys, when they are in charge of installing the launch escape system, when they get it tied down, if they go back in, there's an opening, a port that they can open on the side of the dome, and in through there they'll put this tension tie, and it's threaded, and it threads into the top of the probe head, and in there, that yellow part is a shear pin, and that's ties the boost protective cover to the drogue. Okay, now if we go to the next picture, this isn't actually, if we have an abort as a non-abort, we don't want to damage the drogue, so that shear pin will shear as the launch escape tower is jettisoned off the vehicle, and it leaves everything fine, and the little extension stays with the drogue. I mean, with the launch escape tower.
And a lot of you might not remember that the escape tower has a shell at the bottom that goes over the command module, and the astronauts don't see out the. Is there
They have a window on the
one window.
Yeah, one window on the hatch.
Okay.
That they can look out, but it's to protect during ascent from the exhaust coming off of the launch escape tower.
Amazing, the minutia of all this.
Now, if it's an abort, what will happen is if they abort, they'll also cut the ring off, and that ring will go with it with the docking probe, and all the latches will stay with the launch
Wow.
escape tower.
Huh.
So that they have a clean opening on top of the deck there for the. Eventually, the forward heat shield will be deployed, and then that exposes the drogue chutes, the pilot chutes, and the main chutes. Now, there's a case of where once they're on the second stage and ignited, they eject the launch escape tower. Now, if they still have to abort, then they can just go ahead and cut the whole docking ring off. This is when they would be landing in the ocean somewhere way downstream.
Well, I got a question there before we get into that. Marty, another question from Mark Thal.
Yeah, he's asking, was there a limit as to how many times the command module and service module could be mated or separated pre-flight?
Pre-flight? No. There was I think it was 100 cycles that were told, we were told, because we keep track of cycles, this docking probe could be extended and retracted 100 times. We have launched, that I know of, one time where we only had 2 left. That's how many times from manufacturing to launch. So we only had, I think it was probably 15 or 16. We only had 2 cycles left on that docking probe. Now they would have extended it, but it's
So how about on the way to the moon and back and stuff?
They only can have 4 temps. They got 4 bottles, and that's only 4 temps.
Oh yeah, there you go, Mark. the nitrogen bottles there
That's
to,
the
to release
limitation.
it. You had
Yeah.
four, so you
Four.
had four chances to
Yeah.
do that. Okay. So how many?
Two coming out of the S4B,
Yeah.
and they gave you two for coming off the moon, just in
Okay.
case you couldn't do it off the moon.
All right.
Hopefully you never had
Great
to.
question. Great question, Mark. Okay.
Okay. This is the three configurations behind, plus the one we just talked about previously. The one on the left is called a lock position, and we have a release position, and then we have a cock position. And this is a little too confusing, so I broke it down into three more charts, and we'll talk about the first one here. This is the lock position. This is an Earl Holman, he's famous for this. I don't know how well it shows on the screen at home, but there's three pins, they're called A, B, and C. Then we have the actual hook itself, which is what, teal. We have the trigger, which is in dark green, and it shows two different positions,
Okay.
folded. And then we have a roller, it's in red. It's connected to the spider. And then on each spider, this is all identical for each leg of the spider.
So there's three
legs.
units of
There's three
these.
units. We have a blue link and we have an orange link. And when this configuration it locks it in place, because when you see pin B, it wants to rotate counterclockwise when you fold in the latch itself. And the orange link will go the blue link will go clockwise, and then the orange link will go counterclockwise. And that red roller stops that from happening. Also, I drew a line from the center of the pin above where A is, and through all the way down to C. And you will notice that B is to the left of that center line.
Mm-hmm.
So there's no way that it can back around and go back the other way.
Are you talking about the roller right next to the green red or the big
No, the
red?
roller one is on the orange.
Okay, so
Okay.
you have a tiny red roller.
And
or
that's,
something.
I'll talk about that in a second.
All right.
That's a pin that's tied to the spider.
Okay.
Okay. That's a lock position. Now this is a cock position, and the roller has been pulled down so it doesn't interfere with B rotating clockwise. All right. Now
Mhm.
the red pin is holding this thing up, and the trigger is set in position, and it's keeping the spider from being pushed up by the springs that you see right there.
Mm-hmm.
Now this is actually a release. At a release position, what happens is the trigger is pushed inboard to the second position. That releases that pin, and then the spring will come up, and it'll lock in place then. But this is the cock position right here.
That's cocked, and this
Mhm.
was, and that one.
That's cocked. I'm sorry,
Okay,
cocked.
yeah, you
The other
said
one's
that was cocked,
release.
yeah,
Yeah, the other one's
okay.
release. Yeah, release. And how this works is that spider is on this shaft, and they have a rotating cylinder outside to a stationary cylinder inside, and there's two grooves. There's sort of a 30-degree one right there. As the outer is rotated, it'll drive the rod up, which will put you into a lock position.
Well, this is a complicated system.
It's very
A lot of
complicated.
engineering going
Yeah,
on there
yeah.
with your Mr. Holloman and other people there.
Now let's go back to a couple. Go back one more.
Mm-hmm.
Now, to fire the GN2 bottles, all three of those triggers have to be inward. They're hooked to a micro switch, which completes the electrical connection to fire the plungers. That have a pin that will have an ordnance behind it, a little bit of ordnance, and it pushes down and punctures the bottle. And that's why they could never ever go in and take this once it's extended, because they have to push those three in to get it to retract.
Gotcha. Yeah, I do
Okay.
understand that. Hope
Yeah.
some of you do. Kind
Now,
of
ground,
complicated system, but Gary's made it sound simple.
In the ground, we can do it. Now, there's another issue. I'll get to maybe a little bit later. Is they were talking about, well, we'll just go ahead and go in and remove the docking probe while it's still, in this condition. And if they did, and I'll explain that a little bit, maybe a little bit later on the picture. But if they did an extension where they folded the legs up and they got the probe extended 10 inches, that totally destroys the docking probe. It's totally useless. We cannot, and we were really uh, told by Downey, California, and JSC, never ever do a double extension, because if you do, you send that thing back to us, because we got to tear it all apart to reassemble it. And so if to collapse it with that extended, they can't do it. So it's they're actually trapped right there. They're stuck.
It's a multi-million-dollar part.
Yeah.
Oh, they would be stuck to the lunar module.
They would be, well, they would be,
But there was a way to blow it off.
they would yeah, they would go
you
ahead.
said around the circular.
If they were
power
in the
detonates.
if they were in the slaw, and this thing happened, and they could not, the 6th month failed, then there was no other options that they were thinking about. So what they would do is just fire the docking ring off, and the docking ring and the S4B would make its way to the moon and crash into the moon.
Oh my, wow.
Yeah.
A lot of drama there. So what's this?
This is the docking latch. This was George Campbell's design. There's 12 latches. This is one of them that, in fact, I almost had one of these one day, but I didn't get it. But anyway, each latch had the capability of clamping the two vehicles together. Each latch had the capability of 2,700 pounds pull down capability, for a total, let me get this right here so I don't have to do it in my head, of 32,400 pounds of clamping forces that was holding these two vehicles together.
Oh,
Okay.
a lot.
And so how did they get that force? Well, if you go back to that little round chamber on the side, that nice silver plated one, inside there is a stack of Belleville washers. And we'll go to the next picture. And this is what a Belleville washer looks like. On the right, it takes 2 pulls of the handles to compress them 100%. And the right-hand side, you see them compressed.
Mm-hmm.
And then when the trigger is fired or released, then they'll expand back out, and that gives you your capability to hold down 2,700 pounds. And just go back just one more time to the other one. Now, it takes 2 pulls. The first pull, when they pull it down, it compresses the Belleville washers 50%, but it also raises the hook up off of the ring, off the lunar module. And then they go back up and they pull it down again. And that second pull compresses the springs, the washers on 100%. Okay, and then what also does, it pulls the latch, the hook itself back out of the way, so it'll clear the ring so they can separate when they're going down to the moon. Okay.
Marty, question?
Yeah, Ms. Rothman is asking, what were those components made from?
I guess basically they were steel. There may have been some aluminum components in it. Definitely the hook itself was high grade steel. The blue handle was probably aluminum. I don't know for sure because I never saw it without the blue on it. Blow this up a little bit. There's 2 covers that have been removed. You can see the screw patterns over my head for holding a blue cover that would be over it, and also on the other side where you see the yellow release latch, that also would have a cover on it. Now, there's a button up here.
Yeah, see that latch when button flush or below surface?
Yes, okay. Now, normally this is our biggest problem we had here at Kennedy's, trying to get this thing. The latch, as it comes over, it's violent. I mean, it sounded like a shotgun going off when that thing's hit. It'll come over and slap, and as it comes down, being pulled down, before it's fully retracted down onto the ring, it hits the wall so hard that it'll actually start bouncing back, and we will not get a full engagement. We'll get maybe a half engagement, maybe a quarter of it engage. And so what they had, that button indicator tells you if you didn't get a full engagement, it'll be popping out. And so the astronauts would then go back in there and they'd have to re-pull and recock it 2 more to get each one. And they had to do that on every mission.
Really?
Yeah, and then let's go to a blow up of that. Okay, over there we see the white arrow going to the right.
Yeah.
There's
manual release lever.
Yeah, and Mart, that's the one we need to put your arrow on. Not that one, the one down below, right by my head.
I just had to get to it.
Okay. Right there is a little lever that he would lift up, and that would allow him to totally recock the latch.
Wow.
Okay, it resets it. And once he's cocked it, then he goes over to the yellow one and he pushes that because the trigger's already been
Auxiliary REL.
Yeah,
Auxiliary
really
release.
he'll push that and that'll allow him to fire the latch. And he can do this as many times as required to get a full contact. And of the 12 that are there, all they need is actually minimum of 120 degrees out.
Gotcha.
Okay.
Yeah, I understand. Marty, another question.
Yeah, a Navy veteran is asking, does the ISS still use the same docking assembly technology today?
They use the same system that we used in the Apollo-Soyuz test project, which is totally different because we had to come up with a unified docking system with the Russians, and we saw the ring in the background on one of these pictures here, and it uses 8 different latches. And we do have a model that we finally got out of the case. We have it over here. It's a quarter scale working model. It's been sitting around for 40 years.
Mm-hmm.
And it's a little not working quite properly, but once we get it working right, we can demonstrate how we did it on the Apollo-Soyuz test project, which is also what we use on the space station.
Great question. Great question. All right. Now we're getting towards the end of the program here. Gary's gone always detailed that we just keeps you riveted on your seat here, like me learning about this.
Okay, this is just a side view showing, you can see the, where I got the arrow to, that is the trigger that sticks up out of the docking ring.
Mm-hmm.
And when that's compressed by the lunar module ring, that's what fires the docking latch.
Okay.
This is the probe head. It has a spring underneath of it because the probe head is totally floatable. It'll adapt to any offset that they can have when it goes into the docking probe.
See the latches up there.
Now with the arrow there's a roller pin there, and this is part of it holds it in a retracted position. And I'll show you the other side of this when we go to the next one. This is the solenoid operated latch, and you can see the latch itself is highly reflective silver. And then right above my head is an indicator piece of metal. And what that tells them is as it retracts down, when they mate with the lunar module, when they retract due to thermal loading, whatever it can be, that latch, even though it is self-seating, if it's totally compressed, sometimes the distance between the two vehicles is greater than really what they wanted. And so it doesn't get 100% onto that pin. So there's a shaft, goes all the way down, and let's see if we can see it on the next deal. And this is it right here. It's a combination ratchet wrench and torque wrench. And what they do is they select a certain position, and that little indicator that sticks out has red paint on the bottom side so the astronauts can see that from where they're inside the tunnel. And their goal is to go ahead and extend that latch hook up till it clicks onto the pin. Once it goes flush, then they're good to go, and then they can go ahead and collapse the 3 legs, and then retract the probe out of the tunnel
and stow it under the seat.
Stow it under the seats. Now, normally there's a cover over here with a handle on it.
I see the red arrow at the bottom there.
Yeah, and the bag is probably got the cover and the handle in it. And you can see 2 of the connectors those are temporary stowage positions for the electrical connectors.
At the top and over there on that side, you see the
handle there that the blue handle is the.
I'm looking at the cable, not.
The cable. Now the blue handle is a handle that they use to hold because they're going to have.
Right at your head there.
Yeah,
the hold
right above,
handle.
it is a hold handle, and then right above that, over to the left, is another handle that we'll talk about that is used to collapse the 3 legs. This is the handle itself right here, and it has 2 positions, and then you have a leather level that changes it from 25-degree deployment to 30-degree deployment.
And the final graph for today's program on docking probes with Gary Allgire.
Okay, there's 4 panels. The panel number 1 shows you a configuration as they would have docked with the lunar module. To remove the yellow hatch, which is in the tunnel hatch, they depressurize. They have a valve on there that they can open up so they can equalize the pressure from the 5 psi to vacuum to 5 psi across the interface.
Now, this was a problem suspected with Apollo 11 being 2.5 miles off. That
10.
maybe
Okay, also
the landing, because there may have been extra
Well,
push from the atmosphere.
Not
there.
really, because what they did is in Apollo 10 is what they found the problem is when they went to go ahead and eject the ring. What they forgot about was that I guess they didn't have the hatch in. Yeah, they had the hatch in. That extra 5 psi was in there is what caused it to not crash into the moon. It caused 10 to go into a geosync orbit around the sun.
Gotcha. All right,
And
yeah.
I just looked this up the other day, and in 2037, it'll approach the closest it's going to approach to the Earth.
Apollo 10, the ascent stage, is orbiting the sun. In 2030,
It will approach the closest it's ever going to get during its orbit around the sun. That'll be the closest, which will be 2 million miles from the Earth.
12 years from now.
Yeah.
That might make it.
So they knew
There's
that.
some conjecture when I
Yeah.
read that story that someone may try to retrieve it.
Well, yeah, they got to go 2 million miles to get it.
Yeah, and
I don't know how
match the velocity vector and all that.
That's how, just that little 5 psi caused that.
Yeah. All right, with the other 4 panels there.
Okay.
panels.
Once they remove the hatch,
Number 2.
then they stick out that little blue handle one. They move it out 20 degrees, and it's like a car jack. It's what it's like, back in
Okay.
the old days when we had a bumper jack.
Yeah.
And what they do is they set the lever to the right position, and he just pushes on it, and that will collapse the 3 legs out.
Okay.
Once the 3 legs are out, then are stowed back in, then underneath there's a handle there that he actually can turn, and that will release the capture latches, and then they can pull it out, and then they can they pull the drogue hand out, and then they'll open up the lunar module hatch.
Okay. And this interface right here is my question. Right there, the interface between the 2 that's left.
Yeah.
How is that attached?
You mean the ring right
Yeah,
here?
yeah. Oh, the rings are attached by.
That's the 12 latches holding.
Oh, that's the 12 latches.
12
Okay,
latches
gotcha.
hold that together.
Yeah, that's the 12
Yeah.
latches. That's good.
The other way is if for some reason, for hopefully never happens, is if the command module pilot is knocked out or something, he's not breathing. I mean, he's not able to do this. They can go in and they can actually remove the probe from the lunar module side of it.
Okay.
And let's go back to the other one.
There you are with Edgar Mitchell.
Yeah.
We'll talk about that in a
Yeah.
minute. No,
Go
we
back
got-
to the.
Yeah.
Go back
We got-
and go back to. It's just it was not just one from where we start. Keep going. Keep going. Keep going. Keep going. Keep going. Keep going. Keep
All
going.
right, we're going back to way back here.
A couple more. Couple more.
all right.
Oh, you went a long way. You're going through
Yeah,
the whole
we're-
program. Keep going. Keep going.
Reviewing the whole program here.
Yeah. No, keep going. We're gonna
Okay.
go to a sketch. The one with 4 panels. That's the one we wanted to get to.
The 4 panels.
Yeah, the
That's your.
this one. Where's the?
These 4 panels.
Yeah, that 4
Oh,
panel.
oh, okay. All right. Let's whiz through those there here. Thanks, Gary, for detailing all this. I think it's a refresher course that people now kind of get the concept.
Yeah.
All these pieces and parts there. Here at the Stafford Museum. There's the docking probe on the right, completely different. You're going to have a
That's the
question
docking
about
ring for
for
the
the ASTP.
ASTP, and the ones for the ISS look the same, except the paddles that they're not outward pointing, they're inward pointing. That's the
Okay.
only difference on them.
The control panel, the
Yeah.
up close to the docking hatches, and the cover, how that would have worked out, and then you're going to release hatches, the actual mechanism to put it there, the probe, and then we've got your 4 panels.
Okay, now panel number 4 is if the crew comes in from the lunar module side, they can remove their tunnel hatch after they've equalized the pressure, and this handle has an extension on it, and they pull it out to give them a leverage, and then they can use that jack to that handle to pull that one lever to release the three edge. Now to put it back in, what they would do, let's go up to panel number 2, and what they would do is they would engage the 3 capture latches, turn that handle to lock them in place, and then that handle is what, 20 degrees? They would go out, is it 25, 20 or 30 degrees?
This is 30.
30, okay, go 30. They don't go out 30 degrees, they go out, was it 20 degrees in the panel 4?
Mm-hmm.
Okay, and that allows them to jacket the section A up and engage the 3 legs into the docking ring itself. And then
Excellent.
And then they stow that, and then they put the tunnel hatch on, and they're ready to go. And
All
the
right,
connection.
here you are with the man that
There's
had
the
to
man.
wrestle with this,
Yes.
with Al Shepard and Edgar Mitchell
Yeah.
there signed that for you. That was over on Main Street at our Main Street facility.
Yeah, it's over at the old Nissan dealership.
Marty's got a question for you from Doug Forrest.
Doug is asking, would a docking system used on ASTP have been better for Apollo had it been invented at the time of the lunar landing flights?
If you're talking about the Russian interface side, no, that was developed especially for the Apollo-Soyuz test project. We had some of the Rockwell engineers went over to Moscow with our docking ring. It was still, it was manufactured, but it was not mated to the docking module itself. They carried that thing all over there, and they actually did a docking test over there in Russia with their docking system and our docking system before they were actually mated to their vehicles.
Thank you, Doug Forrest. Great question. Thank you for an
Yeah.
awesome inside look at our space vehicles. One little component, the docking hatch.
Yeah.
Can you believe there's so much engineering and
Can you
and
go
thought
to the
into
picture
it?
with Ed Mitchell?
What?
The picture with that. There
Yeah.
you go. Now, we talked to Ed Mitchell. The lady was doing the interview, and I just happened to be there, and I took my phone out and said, okay, I'm going to start filming this too for my personal library. And Ed Mitchell talked about the Bibles. I don't know if you've ever repeated that.
I mentioned the microfish of the
Microfish.
Bible. That was a small, little, tiny.
Well, they were microfish, and he said that originally, Ed White, they were trying to get the Bible into space, and I think there was a minister or preacher in the Houston area that was sponsoring this, and he went to Ed White and asked him if he would carry that up, and he said he would, but he passed away before they could actually do that. So they tried Apollo 11 and Apollo 12 because now they wanted to put on the moon. So they approached Ed Mitchell, and he told him, he says, well, yes, I like the idea, and he says, if you could make it so it can fit in my PPK, which is a personal preference kit, he would take it with him as long as it also didn't add any weight. So they had a microchip. They had 100 microchips in there. They had 100 Bibles. I think, I didn't catch it on mine, but I think he said that the Bibles were printed in all the known languages on Earth at that time.
Gosh, what an
Okay.
amazing accomplishment.
Yeah, and he carried them onto the moon on his mission, brought them back in, and when he landed, he gave them back to this gentleman's name was Stock, Kevin Stock, I think was the minister. Gave them to him, and he passed a lot of those out to friends in the area, and then they were sold to another gentleman, and then last he remembers of anything on it is the gentleman that started Hobby Lobby wanted some copies, so he bought some copies from the gentleman that had bought it from Stock, and then he had to go and have a photograph with him, or a video of him talking about it, so that he had to give it the provenance that yes, I did have these on the moon with me.
And Edgar Mitchell talks about that on YouTube. Just
Yeah.
put his name in. It's about a 7 to 10 minute interview there. Not much about it,
And
but
you'll hear my voice because I'll ask him a question about the docking probe.
there you
And
go.
his memory at the time was about as bad as mine because I asked him where the docking probe went, and he says he thought it went with the excuse me, with the lunar module, when actually they brought it back.
Well, we appreciate that. Give you a little history of Apollo 14. Let's head it down to the moon real quick as they separate there. Again, the docking probe sticking out there, as you see. And there is Antares on the surface of the moon, Kitty Hawk with Stu Rosa orbiting. And Marty, there was some concern of the tilt of that. There, as we look at the back side, you have a comment about the amount of tilt that was permitted, or what was the thinking of the Grummies when this was happening, Marty?
I don't recall the thinking, Mark, and I offhand, I'm sorry, I forget what the tilt limit was. I want to say 15 degrees, but I may be way off.
Yeah, you were working on 15, 16 at that time, trying to adopt the LEM number 10. Actually, 9 was scuffed after this or scrubbed, and that's now out of Kennedy Space Center. So always fascinated by this side of it when I see LEM 9 out there. It looks just so, that ink canal just looks like you can touch it and move it around.
I think, as engineers here at the Cape, we really don't, we're concentrating on what's here on the ground. And once they get into the flight, it's kind of, we let that go to JSC and you just monitor it. So you don't get the details and maybe some of the things we should know because it's not part of our job description.
There was no internet back then to track everything.
Yeah. We were awful busy.
As we look at they had, the commander had the stripes on. I don't see the stripes on that.
And it was the first time they did that.
That's the rickshaw that they used to take equipment and up to across the lunar surface. That was very thick regolith, the thickest that we ever walked in. There's Kitty Hawk out of Kennedy Space Center. And there it is on the moon, as the moon is up in the sky like a big pizza pie. That's the More. And you're going to be seeing the moon full phase a week from today, next Wednesday. But that is where Apollo 14 landed, the Fra Maro region of the moon. That was a very old part of the moon. We landed in the darker areas. Actually, Apollo 13's right there. Apollo 11's right there at Mare Tranquility. Apollo 12, not too far, a little bit further to the left of the circle, is where Apollo 12 landed. But this one landed in the highlands. It was much older, almost 1 billion years older, in soil that had been thrown up. These mountains of the moon are not tectonic mountains like we have, or volcanic. They were caused by these asteroid impacts that created the circular lava dark areas there. So, and got a repeat a picture that Carlton Bailey had autographed by them training out there with the armadillo in the foreground.
Yes.
How often did you see an armadillo out there?
I've seen, not out on the Space Center, but I've seen them around the house, and I've seen them when I ride my motorcycle.
Squashed on the road.
No, I've tried to go into Sebring one night watch a car race, the 12-hour car race down there.
Mm-hmm.
My first encounter with an armadillo was in the center of the road, and I figured I would just center the car and I'd just pass right over him because he wasn't moving, and all I got was a big kaboom, and I didn't understand why I hit him because I had enough ground clearance. It wasn't much later that I found out that when they get scared, their natural reaction is to jump up in the air.
Oh, really?
It jumped up and hit my bumper.
My gosh. Stories of all kinds of critters out there at Kennedy Space Center.
And you don't want to mess with them.
Before air conditioning. Are they mean?
No, they carry disease. They carry a disease that you can get, which is not a good disease.
Yeah, well, I don't want any disease, okay?
You get leprosy from them.
Leprosy,
Yes.
holy cow.
I know, I have a friend that did. He always captured them and relocated them, and he ended up getting leprosy.
Oh, yeah.
Yeah, they can cure it.
Well, look here. There's Mitch Rothman of Manned Space with Edgar Mitchell there. Surprise, surprise, Mitch. A few years ago, it looks like, out there. I don't. Mitch never told me. I know he met him. I'm not sure what this was, but probably a little formal dinner there. But he really gave a lot till he passed away.
He
And
was a very
Mitch is telling me he died in 2016 on
yeah.
the date he landed on the moon, February
Right,
5th in 2016.
He was a very nice man. I mean, very easy to talk to, and he was more than helpful to give you answers back.
He's
Because so many
deep,
astronauts won't give you anything, you
Yeah.
know, like Wesley Schweiker did.
And another surprise for one of our best viewers here is Doug Forrest promoting Doug and his ApolloArts.com. Here's some samples of his fabulous pencil work. Please help Del go and check this out. And if you feel like buying something, that'll help him buy his ticket to Shuttle Fest here.
Yeah.
So we want to promote Doug all we can. Look at this fabulous work of the famous golf ball shot. Although it was a fabulous mission, unfairly, this is what people remember is the golf balls.
How far
on
did
the
the
moon.
ball go?
For miles and miles and miles,
Yeah,
right?
that's what he said.
Yeah.
It didn't.
He shanked the first one.
Yeah.
This is Laura, his daughter, telling
Yeah.
me. He shanked the first one. She thinks he may have picked that one up, put it in his pocket, and
Okay.
brought it back. All right.
Probably did.
But she didn't get it.
Yeah.
There's a story that Carlos, his hair barber, got it, and then he hit a couple others, and you can see that. But what a great perspective, what a great eye, and what a great artist Doug Forrest is there with 2 R's. So check him out there at ApolloArts.com. His wife Yoshiko and him are coming to Shuttle Fest 4. You'll get to meet him.
Okay.
A great guy, and his wife's awesome. And he works in the industry out in Los Angeles and Pasadena, doing graphic arts and all that kind of stuff, Doug. So thank you for staying curious, everybody. Mark Geiger has. Reading the history, they thought at the time while sleeping they were tripping over because of the angle. Oh, okay. Mark Geiger says that they had a hard time sleeping because the angle was such on
That
there. It was
could be.
messing with them. And hey, you put me on an angle in my bed, I'm not going to have a good night's
Well, some
sleep.
people like a heads up angle, but if it's sideways, or you're wanting to roll out of the bed, that's not good.
Mm-hmm. Well, thank you, Gary Allgire. Another
welcome.
fabulous
Yeah.
program there. Detail like you're not going to get anywhere from any space worker except space workers here on the American Space Museum Stay Curious channel. Thank you, newbies, for showing us. Check out our auction. Go to our website. Hit the QR code. Start looking at these awesome. It's an awesome auction again, Marty. There's all kinds of autographs, crew signed autographs of the shuttle, just things that you'll never find anywhere else. And this is not yard sale stuff, okay? You're going to spend $100 because that's the minimum bid on any of these lots, and they're well worth it at that price. So thank you, Steve Jokums. He enjoyed your visit today, Gary. Tom Celentano saying always informative. And our Navy veteran says, great show. Thank you, everyone. I really enjoyed the video. Stay safe, as did and great info, says Mark Geiger, Gary. And they're just not going to get this information anywhere else. I know they're not interviewing people at Johnson Space Center like we are.
Yeah.
We love having you on. We have other people on. We want you. Have you signed the board yet of your guests here? Make sure you do
Not
that
this
before
one,
you leave.
But just to tell you that I'm the only last one left that knows anything about that is here at Kennedy Space Center.
There you go.
Yeah, I'm the last person.
Well, keep taking your vitamins and
Yeah,
doing the right
yeah.
thing
Well, I don't know.
there, and take care of your wife
Yeah.
there, because I know you've been partners for an
Yeah,
awful long
yeah,
time, and you feed
57
off
years,
each other.
yeah,
So
Yep. So,
thanks again, my friend. You're
Okay.
always a delight on our program here. Marty, we're going to talk some about a little more Apollo 14. About this patch that I own, huh? What's the Coyote and the Roadrunner have to do with Apollo 14? I know Steve Jokums knows. All right. And so is probably Mitch Rothman. But yeah, that's a patch I have. And we're going to find out how much that might be, though we don't have one in our auction. A way to deal with our auction tomorrow, space history. We'll do some current events. And then Friday, we'll do a little bit of backyard stargazing for y'all. Be looking at the moon all weekend. So thank you, Mary Geiger, Mark Thiel, Elena Adhekara, Dave Stangy, Doug Forrest, USSLKA 116. What do you think that was, Marty? A destroyer? You're a Marine.
It's a ship. That's all I know.
It's a ship. All right. The USS gave it away to Marty.
Yes,
Then it must
yeah.
be a ship.
Yep.
We appreciate you newbies out there. We need you. We love you. You're going to learn so much, not just from me, but all kinds of guests on our show. Mitch Rothman knows that. So is Tom Cilentano, Gary Gerald, Dean Babcock, Steve Jokums. There's Carlton Bailey and Cliff Watson in Australia, and my good friend Tommy Usiak there in Lancaster, Pennsylvania. So, and thank you, Martin R. in there. So until tomorrow, Gary, you're going to probably be watching. Please watch to keep me honest, would you, on there. Till tomorrow, I'm Mark Marquette saying we can't wait to see you again to bridge the space between us.